Hello, my name is Zhongting Guo. I'm a faculty at Biomedical Informatics and Data Science or BIDS, as well as surgery at Yale University. It is my pleasure to talk about blockchain technology and smart contracts with encryption. So let me start from the concept of blockchain. So it is a long underlying decentralized technology of cryptocurrencies. Thus, different coins might have different implementations, such as Bitcoin, Ethereum, etc. It is also considered as a new way to share healthcare data, for example, clinical trials or COVID-19 and many more. So for blockchain, it is a new form of ledger to store data. So this is a very simple example of blockchain. We can see that the data are recorded in transactions. For example, suppose I send 20 coins to my friend. This is considered as a transaction, in this example recorded in transaction T11. And then the transactions are enclosed in blocks. In this case, T11, T12, and others are enclosed in block B1. And then blocks are chained using hashes to order the transactions and therefore the data within the transactions. So as we can see, in order to create block B1, B2, we need to have block B1 first so that block B1's hash can be recorded within block B2. This ensures that all of the transactions within block B1 need to happen before all the transactions within block B2. So with this, let's take a look at how this blockchain is created, and then we can understand what benefits blockchain can bring to us. So this is a simplified example of a Bitcoin blockchain creation process or a mining process. So suppose there are 4 computers or 4 nodes in the network. Each one want to submit a transaction to record some kind of information. And then the first step is that the transaction are broadcast to the entire network so that everyone has the same set of transaction pool. Then each node pick 2 transactions in this example and then start to solve a difficult mathematical problem. So suppose node 2 get lucky and then solve the mathematical problem first. So now it has a privilege to create the first block 1 and then enclose the transaction 2 and 3 of its choice. And then node 2 also gets some reward, in this case, some Bitcoins. Then node 2 broadcasts this block to the entire network, and then every other node can check whether that block is valid or not by checking whether the mathematical solution is correct or not. If so, let's start doing the computation and then remove those 2 transactions from their transaction pool because they are already in block 1. So in this sense, block 1 is complete. Then the next iteration, each node again choose 2 transactions from the transaction pool and then start to compute the difficult mathematical problem. So suppose this time node 3 get lucky to get the next block by solving the mathematical problem first and then get some reward. Then again, node 3 broadcasts this block 2 to the entire network and everyone check if it is correct, stop mining, and then remove the transactions from the transaction pool, then agree that this should be the next block. So we basically repeat this process. So as we can see, after the whole process, each node will be able to see all of the transactions of the blocks, and there is no central server to manage the whole process. And as we can see, no single node can easily change the content of blockchain because everyone can validate. And also the source of the transactions and blocks are verifiable because everything needs to be broadcast to the network so everyone can see where the source is. So beyond cryptocurrency, blockchain is also considered a new form of distributed ledger so that instead of storing monetary transaction information, we now store data within each transaction using transaction metadata. And then specifically for non-financial applications, we can configure blockchain as either permissionless or permissioned network. So for permissionless, it is more like a public one that everyone can join, every computer can join. And then for permission, it's more like a private one, only allow computers can join the network. It is also somewhat similar to the internet versus VPN. So for healthcare, blockchain has several benefits compared to traditional distributed database, such as decentralized management, as we just mentioned, no central server, immutable audit trail, and data provenance that we already talked about. And then availability, this is because there is no single point of failure. So even if one of the nodes stop working, the other three nodes can continue create the blocks. And then also there are additional security measures being added to the design. And then since blockchain can be used to store data, people start to think about whether we can go one step further to store program or computer code also on blockchain. So those code are called smart contract. So the idea is that we now not only store data, but also store programs on chain. So this can bring us several benefits. So the first one is that the code now becomes transparent because everyone can see the code. And then the code is immutable. No one can change the code by themselves. And then also the code will be source verifiable because everyone can see who deploy the code. So to summarize, the technical benefits of blockchain to store data include decentralized management, immutable audit trail, data provenance, availability, and security. And then for program smart contracts, it has the benefits of code transparency, immutability, and provenance. So, however, there are still some challenges of blockchain, such as transparency, which could be a good thing, but sometimes in some use cases, it might not be the ideal setting. And then scalability, whether it is scalable when we want to store more data on chain. And then 51% attack, this is based on an assumption that in order for blockchain to work properly, there need to be more honest nodes or computational power than malicious ones. So if this is not true anymore, it is called 51% attack. There are several other challenges, but today we want to focus on transparency, which everyone can see everything on chain. Again, it is sometimes a good thing, but sometimes might not, depending on the use case. For example, so in the use case of data analysis, we can see that researchers might want to analyze patients' data. However, patients might want to keep their data private. So, and also privacy regulations will need to be followed. So in this case, putting patients' data directly on chain will not be a good idea because then everyone will be able to see the data directly. So in this sense, how about let's try to see if we can incorporate the idea of homomorphic encryption to enhance privacy. So here I will use one example from a paper published in 2021 by a research group in this information processing and management journal. So in this example, it is about data aggregation. So the idea is that suppose an asker in our example, it is actually a researcher A want to aggregate data for a query queue, for example, sum of some values from 4 participants. In our case, we can consider these participants as patients. So these participants in this figure, we can see are O, P1, P2, and P3. So O is an operator, which is a special participant. It can be any of the 4 who initiate the process. So again, if we just use a plain blockchain and smart contract, then we get the benefits of immutability, but they are transparent. So the plain text data will be seen by all parties, which is not ideal. So intuitively, we can just ask all participants to encrypt their data using a shared public key. However, blockchain is transparent, so still, if we have a single key, private key owner, that owner will be able to decrypt everything and then see all the data. So the design, ideal design will be that if this trusted private key owner role can be avoided, then the participants might feel better to might feel more willing to share the data because they don't need to worry about their data being seen by that private key owner. So that's so the design is as follows. It contains 6 steps. So the first step is aggregation query. So the asker A first send the query Q to the operator O. Then the asker A also share its public key KA to the blockchain. Then the operator first obfuscates its own data. So the idea is that the original data of operator O is V, the value is V, and then it added by a random nonce N to be obfuscated data D. So then operator O encrypt D using its own public key KO, so it becomes DKO. And then the operator O also encrypt the nonce, random nonce N using asker's public key KA, so it becomes NKA. So now operator O shares KO, DKO, and NKA to the blockchain network. Then the next step is that each participant now also obfuscate their own data with a random nonce, and then they encrypt their data using the obfuscated data as well as the nonce DKO and NKA, and also share them to the blockchain network. Then the smart contract, recall that it is a program run on blockchain, homomorphically adds all the results RKO as the sum of DKO. So since it is a homomorphic addition, so it can do this without decrypting the data. Then operator O wait until all of the DKOs are homomorphically added. And then basically after this step, all the other participants P kind of finish their computation. Then in the next step, operator O first obtain the obfuscated result RKO from the smart contract. So recall this result is the aggregation of all real data plus the aggregation of all random nonce. So operator O decrypt the obfuscated result R via its own private key. So in this sense, operator O also get a result. It is obfuscated because it is still with those random nonces. Then operator O re-encrypt this R using asker's public key KA becomes RKA and then share the RKA to the blockchain. So in the final step, the asker obtain RKA and all 4 NKA from the blockchain. And then since these are all encrypted using KA asker's key, the asker can now decrypt all of the obfuscated result as well as the 4 random nonces using its own private key. So in this sense, asker A can get a real result by a non-homomorphic subtraction R minus sigma N. So let's see what all of the parties can see in this design. So the participants can see the real data, but only for their own real data. They cannot see other people's own real data. And then operators can see its own real data and then obfuscated other people's data as well as obfuscated results. And then the asker can see the real result, which is the aggregation, as well as the obfuscated results. So as we can see in this design, no one can really see real value of the other people. So, so essentially, the trusted role of the private key owner in this design is split to operator O and asker A, so that no single party will be able to decrypt the real individual data. So, so for the implementation and consideration in this study, it used Palier partially homomorphic encryption for the addition computation. And then they use Ethereum blockchain with Solidity smart contract. However, within the considerations, a specific one is the possibility of collusion of operator O and asker A. This is because O can see each obfuscated data D, while A can see each nonce N. So if they collude, then together they can both see the real individual data V by simply compute D minus N. So in this paper, there are several possible solutions proposed, but then this is still a research direction that can see how to further improve this or avoid this collusion situation. So so after this, so I have briefly introduced blockchain smart contract as well as an example of homomorphic encryption. But then we also have several other related biomedical blockchain studies listed in this page. So if you are interested, please feel free to take a look. So to conclude, today we talk about the blockchain, which is a distributed ledger for data, and then smart contract, which is the code stored and run on blockchain. And then we talk about homomorphic encryption to enhance privacy on blockchain, and then use an example to introduce the possibility to enable privacy preserving data aggregation. So this is really a new research field to be further investigated. So I would like to thank all of my funding sources and would like to take any questions or comments. Thank you very much.